Chapter 8, Section 3, Properties of Acids and Bases. The first thing we need to look at is what is an acid. It's any compound that produces an H3O positive ion. It's called hydronium, and that will dissolve in water. So we're looking at any type of acid, really, that will have a sour taste. Those will mostly be acids. So think about lemons, grapefruits, limes, oranges. Those all contain some kind of a citric acid. These will react really well with metal. So if you use aluminum foil to cover up some kind of an acid, it'll usually change the color of the aluminum foil. And it will also produce a color change in what we call an indicator, and we'll talk about those in just a minute. But based on the type of indicator you have, it will change things differently. Acids are also known as proton donors. So that means they have extra protons that they can combine to ionize. So common acids that we can look at, acetic acid, so that's vinegars that you see. Carbonic acid, so think about your carbonated beverages. So your colas, your Pepsis, all of those things have carbonic acid. Hydrochloric acid, that's your digestive juices, that helps you to digest your food properly. Nitric acid and phosphoric acid, both of those are found in fertilizers. And then sulfuric acid is found quite often in car batteries. Now, a base is the opposite of that. A base is a compound that produces an OH minus, which is hydroxide, when it's dissolved in water. These will have a bitter taste, so unsweetened chocolate. So think about like natural dark chocolate, that's the actual Keiko. Other things, just think about medicines. Those are usually bitter tasting. It's not something you really want to taste of. They'll be very slippery, so kind of like wet, soapy feeling. Because it's dissolving those compounds, it's trapping that stuff in. And then it also produces a color change in an indicator. And again, we'll talk about that in just a second. It's called a proton acceptor. Because it is negative, it's more likely to gain something that will help it to neutralize. So common bases, aluminum hydroxide, that's used in your deodorant or in stomach antacids. So if you have digestive problems, so that hydrochloric acid in your stomach is upsetting you, you can take an antacid, which is a base, which will kind of counteract that. Magnesium hydroxide, again, that's antacids, laxatives, those sort of things that kind of help to settle an upset stomach. Sodium hydroxide, drain cleaner, soap production. That's what you have in your soaps that you use in the shower. Your drain cleaners to clean out all that gunk from the drains. Now, the color change in the indicators depends on what type of an indicator you are using. The most common is litmus paper, and it comes in two different colors. It comes in blue and it comes in red. And the easiest way to look at this is that if it is something that is a base, then you would want to use red litmus paper to determine that. If it's something that is an acid, you want to use blue litmus paper to determine that. And the reason why is that if it is truly an acid, the blue litmus paper will turn red when it is applied to that acid. And if it is truly a base, that red litmus paper will turn blue in response to being activated by that base. And we also have what's known as neutralization, and that's when we have an acid and a base that reacts. And that's what I was just talking about when I said that the hydrochloric acid in your stomach reacts with the antacid and it kind of neutralizes that situation. So Tums, Rolaids, those sort of situations will help to neutralize the acidity because it is such a base. When you are doing neutralization, it will give you water and a type of salt for your body. And we're going to look briefly at the strength of acids and bases. So some are stronger than others. And this is section 4, and this will be the last thing. So it's all based on pH, and it's actually a measure of the H3O plus concentration. So it's more based off of your acids instead of your bases. So the lower the pH, the more of an acid that it is, the more H3O plus, the more hydronium it has. The higher the pH value, the less of that it has, the more hydroxide it has, so the more of a base that it is. So low numbers are acids, high numbers are bases. So let's look at the scale. So here we have 0 carbattery acid, so that's sulfuric acid, that's your lowest, that's the most acidic. Moving up to a 2, that's your lemons, those that have a lot more acid in them. 2.5, vinegar, it's right here in the middle. Oranges are sitting about a 3.5. Tomatoes, are 4. White bread, not wheat bread, white bread, which is what most of you eat, is about a 5.5, close to a 6. Milk is pretty neutral. It is 6.5, 6.6, somewhere around in there. Distilled water is your 7. So you can see that here. I've kind of cut the chart in half. Distilled water is a 7. It is your perfectly neutral. Now that's distilled water. Actual regular tap water or mineral water that you get is a little bit more basic than that. So it's somewhere between a 7 and an 8. Baking soda sits at 8.5. Soap that you use, a 10. Ammonia, this is a cleaning product, 11.5. And then drain cleaner being your most basic all the way down here at a 13.5. So keep all of these in mind as we look at different acids and bases for your assignment today. And that's it.